will just give us the position, which is basically x plus epsilon x times. So similarly, if I try to find out what is my generator E epsilon x operating on the state, okay, what will it be? First, we will evaluate this one. So that will be equal to what? E epsilon x. And then this one will just give us x times, right? X being a number over here, this is just a number, right? Number. So then what will happen? This will come to the left of the operator. This will be equal to x like this, right? And then that will be what? T operating on x. That will be this will just generate, right? So x, and this will generate x plus epsilon x. Okay? This is what we will get from this expression. Okay, and once we evaluate this one, we will get this. So if we try to evaluate x, x, e epsilon x minus e epsilon x, this thing operating on the scale. Yes. So this will be equal to x, e epsilon x operating on x minus e epsilon x. But this one and this one we have already evaluated. You can see this is one, this is two, and then it will be equal to from one we have x plus epsilon x, that will be x plus epsilon x times x plus epsilon x. Okay. Minus x, x plus epsilon x. Okay. Now, if we try to evaluate this one, this will just be equal to epsilon x. All right. Is it clear up to this point?
Yes, sir.
So that is in your material. It is question number 1.22 on page number 16. Right? If you are referring your material, then it is page number 16. Block them. All right. Now let us try to see what is the state x plus epsilon x. x plus epsilon x plus epsilon x. That is it. This is basically we find by the generator. So this is nothing but E epsilon x operating on state x. Now we have already discussed that this T generator of operator, the translation operator, can be written as identity minus I epsilon of k k, right? Operating on yes. Right? So this is like state x minus I epsilon x, yeah, x operator. Now if I write what is epsilon x this step, you can just multiply epsilon x to the left, what exactly I will get? I'll just substitute this one, right? So this will be epsilon x times L minus I epsilon x square here. Yeah. That is basically your equation number 1.24. Now here, this term is neglected as epsilon x square is very small. So then we are only left with this part. Okay. So what we can write? Epsilon x plus epsilon x square is nothing but epsilon x. Okay. So if we substitute this, let's say equation 3, equation 3, where yes, then what we will get? X t minus tx. It will get x t minus tx operating on x will be equal to epsilon x. But this part is nothing but the commutator bracket, which is essentially equal to x t epsilon x commutator. That will be equal to epsilon. So what exactly is happening? The commutator is basically giving you, the commutator is basically giving you the small change in translation. K commutator is equal to epsilon. Okay. But you know, if we multiply identity from left or right, it will be the same operator. So that's why this first term will go to 0. Why? Because xi minus ia are basically same. They are not different. We multiply identity matrix or identity operator from the left or from the right, it gives you the same operator. Okay. So that is why what we will do. So minus I epsilon x. Then this part. X square, x square communicated is equal to epsilon x. Isn't it? Or by rearranging, what I will get? Epsilon x will cancel. Minus I, if it goes to the other side, so this will be minus I x square commutator is equal to 1. So x kx commutator is equal to 1 by minus I, which is equal to I. So this is what I can write. X kx commutator is equal to I. So that is nothing but your equation number 1.27. So there are two conditions. There are two conditions involved in this case. Let me remind that. Condition. There are two conditions. What? Number one, that epsilon x is infinitesimal, very small. Epsilon x is infinitesimal, very small. Right? All right. Second one is k is Hermitian. K cap, kx cap is Hermitian. And this should represent something physical. Okay. So similarly, if this is in uh, this is in one dimension, we can simply write in three dimension, and in three dimension we can write down the commutator relations. The commutator relations. What are the commutator relations? Generalizing to third dimension. Three dimension on x is equal to y divided by y k is equal to y. Now, what is the meaning? What is the meaning of this commutator not being zero? If a commutator is zero, that means we can simultaneously determine the quantity. Suppose A is a quantity, B is a quantity. If you have operator A and B representing the physical quantities, if the commutator is zero, that means we can simultaneously determine the value. But if the commutator is not zero, that means we cannot find out simultaneously the values of those two operators. Eigenvalues of those two operators. All right, is this clear?
Yes, sir.
So next we will move over to momentum as a translation generator. momentum as a translation generator. Okay. So let me go to the material. Once you understand this mathematics, then you should be able to. So next we will start this one. And it says you have already seen how the momentum enters into the translation operator kx. So here the function it is in terms of kx operator. Okay. We arrive at the same conclusion from the formal definition of translation operator. Notice that the commutation relations proved in equation 1127 so that the commutation relation of operator k with the position operators are similar to those between momentum operator and position operator. So this statement is very important that relation proved in equation 1.27. 1.27 is basically your this relation x kx is equal to y or for that matter this relation. Okay, x kx is equal to y, y ky is equal to y, and z kz is equal to 5. Okay, now this is similar. The commutation relations of these operator, position operators are similar to those between momentum operator and position operator. ସେଠି କ'ଣ ମିଳେ ମନେ ପଡୁଛି କି? X px. If we take x px, what do you get? Commutator कले quantum 1 रे पढ़ा है. Can you repeat? IH cross, right? You remember? Yes. Isn't it? So this relations, so that it is very important that we get I over here. Later on, you will see that this H cross being taken as unit length, so that can be equal to 1. Later on, you will see in many mathematical calculations, we take H cross to be equal to 1. But we'll see whenever we come to that part. So at this point, he says we invoke a concept familiar to you from classical mechanics. What is that? That in the unit on canonical transformation, I think it is being taught right now, right? In classical mechanics.
Yes,
Right? Canonical transformation.
sir. Sir.
Yes. In the unit on canonical transformation, you must have studied that the infinitesimal translation can be written as the following canonical transformation. What is that? So Q goes as Q plus delta Q, and P generalized momentum becomes P only, right? So the generating function for this transformation, the generating functions were 3, 4 type generating functions. पढ़ा है नहीं? Generating function classical physics
Sir.
पढ़ा है तो? So then what we can write is QP constant QP plus delta QP, right? QP and delta QP. So ସେଠି ଯେମିତି generating function ଥିଲା ଏଠି ସେମିତି generator ଅଛି. ଠିକ ଅଛି? ଏଠି ଯେମିତି generating function, efficiently generated. Okay, so this is kind of a uh, correspondence from classical physics, Hamiltonian dynamics to quantum mechanics. All right.
Yes, sir.
Okay. I'll take a couple of minutes pause, have a cup of water, and then I'll come back. Okay. All right. Let us start. So let us come to page number 17. It says that, so it seems reasonable to infer that the operator kx is related to the momentum operator somewhere. However, it is also necessary to quantify epsilon x kx be dimensionless, for which kx must have unit of universality. Therefore, kx cannot be px. However, we can take kx to be equal to px by h cross. Then the dimension of k cap would be f of x. So because all of you know that whenever we units and dimension, you must have studied in the very basics in +2 level. Right? The equation has
Yes,
to,
sir.
to be consistent from dimension point of view. So here, just by analogy, just by comparing, we are claiming that kx will be equal to px by h cross. Kx will be equal to px by h cross. Okay. So if we use that, then our px, which is the translation operator, will be equal to I minus I means identity minus I times epsilon x px x cross. And if for x direction, it is epsilon x px. For y direction, it will be epsilon y py. For y direction, it will be epsilon y py. For z direction, it will be epsilon z pz. So if we combine that, it will be basically epsilon x px plus epsilon y py plus epsilon z pz, which is nothing but epsilon vector dot p vector or pk. So that's what in three dimension will do. So momentum is the generator of, this is a very bold statement, momentum is the generator of infinitesimal space translation. Momentum is the generator of infinitesimal small space transition. What is Newton's law? Newton's law says an object will be at rest or move with constant speed until and unless a force is applied. Right? And if a force is applied, so then there will be acceleration, and then our body will move. So force is the cause. So here also, for change in position, momentum is the cause. Unless the body has momentum or is provided with momentum, the body will not move. So that is why momentum is the generator of infinitesimal space translation. So if we take n times, n times, so that will be equal to, so here say, we can say that an finite translation, try to understand this part, is very important. We can now say that the finite translation. Earlier we were telling infinite decimal small translation. Now we are telling finite translation, epsilon x, is made of n number of infinite number of translations of magnitude epsilon x by n with limit n going to infinity. ବୁଝି ହଉଛି ପ୍ରଥମେ କହୁଥିଲା
Yes, sir.
ପ୍ରଥମେ କହୁଥିଲେ ଯେ ଇନଫାନାଇଟେସିମାଲ ସ୍ମଲ୍ ଟ୍ରାନ୍ସଲେସନ ପାଇଁ ଜେନେରେଟରଟା ହଉଛି କିଏ ଟି ଏପ୍ସିଲନ୍ ଏକ୍ସ ଯାହାର ଭ୍ୟାଲୁ ହଉଛି ଆଇଡେଣ୍ଟିଟି ମାଇନସ I epsilon x dx by h. But the three dimension number, well, identity minus I epsilon vector dot p vector by h. Now, ସବୁବେଳେ ତ ଆଉ infinitesimally small translation ହଉନି. We have actually finite translation. ତ finite translation ହେଲେ କଣ କରିବା ଆମେ finite translation epsilon x କୁ ଯଦି ଆମେ finite translation ନବା ତାହେଲେ ତାକୁ n number of infinite translation ରେ divide କରିପାରିବା. And each step of that finite translation will be equal to epsilon x by n, where n going to infinity. If we substitute that, if we substitute that in equation 1.32, we have equation, let me erase few things. We have equation 1.32 over here. Right? equation 1.32. If we substitute there, because our epsilon x will be replaced by, in this case, our epsilon x will be replaced by epsilon x, right? And so if we substitute that, and what will happen? We have to one by one, one by one, one by one. We have to do this translation, so that will be getting multiplied. Because let me write down, then maybe you will understand. So let's say I have n number of states. So what I will do? I will first operate p epsilon x by n, operating on state x. Then on top of it, I will again operate p epsilon x by n. Then again I will operate t. This is how I will do. And what it will produce? It will produce what it will produce? It will produce this matrix over here. So that is why to the power, that is why to the power n. Okay. So I minus identity minus I epsilon x p x by n h cross to the power n. This is nothing but, if you do a expansion, it will nothing but the exponential function e to the power minus I epsilon x px by h cross. Okay. So that's why we can simply write we can simply write the state vector x plus epsilon x plus epsilon x is equal to exponential minus I epsilon x px by h cross x state vector. So for finite translation in 3 dimensions, this is the earlier value. This is whatever we have got. This is for infinite decimal. Infinite decimal. Very small. Very small. Okay. But for finite translation, what we will get? E epsilon is equal to e to the power minus I epsilon minus epsilon dot p by epsilon. This is what difference we have. For this is for finite, and this is for infinitesimal is small. Are you clear about these two facts
Yes,
for
sir.
finite translation and infinitesimal small translation?
Yes, sir.
Yes, sir.
All right. So I guess you can try this small answer type question afterwards. Yeah. So as you can see, this is for finite translation. That's why it is showing exponential part here. Okay. Next, we will move over to rotation. And for translation, now we will move over to rotation. Okay. So what exactly is being done in rotation? It says, as we have done for space translation, let us first look at how the wave function of a particle changes with rotation of the system. ତାର ମାନେ wave function ଟା translation ହେଲା ବେଳକୁ କେମିତି change ହୁଏ ସେଟା ତ ଆମେ ଜାଣିଲୁ। ଜାଣିଲୁ କଣ? ସେ translation ଟା କେମିତି generate ହବ ତାର generator ଟା ବି ଜାଣିଲୁ ଯେ ସେଟା ହଉଛି momentum। ତେଣୁ momentum apply କଲେ ହିଁ translation ହବ। ବର୍ତ୍ତମାନ କଥା ହେଉଛି, so let us first look at how the wave function of a particle changes with rotation of the system. Rotation ହେଲା ବେଳକୁ କେମିତି? So consider a three-dimensional space function psi r, which is basically a function of x, y, z, psi x, y, z. And after rotation, the wave function changes to what? X prime, y prime, z prime, or you can tell psi alpha. Okay, r goes to alpha. So in that case, if it is rotated about z axis, if it is rotated about z axis, then from this you might have done in classical mechanics, Euler angles as well. Have you done it? Classical physics रे करछे कि नहीं?
हाँ सर।
ये rotate करले cos x minus sin x cos x এই ভଳିଆ formula ଆସିବ ନା? So this is what you will get. X prime will be equal to x cos theta minus y sin theta. X cos theta minus y sin theta. So that will be like then cos theta minus sin theta, then sin theta and cos theta. Are you getting it? Or maybe I should write it. X prime, Z prime, cos theta, sin theta, theta, ଏଇଭଳିଆ କିଛି ପଢିଥିଲ classical physics ରେ? This is the rotation method. So if you use that, then x prime will be equal to x cos theta minus y sin theta. Y prime will be equal to sin theta plus y prime. Okay. So this is what you will get for rotation, isn't it? Now, if theta is very small, if theta is very small infinitesimal rotation for infinitesimal rotation, theta is very small. If theta is very small, then what we can write? Sin theta goes to theta, and cos theta goes to 1. All right? Getting my point? So then, these three equations, what can I write? So my x prime will be equal to x cos theta. Cos theta is 1. So that will be x minus y theta. Similarly, y prime will be equal to x sin theta. Tan theta is theta. X theta plus y cos theta. Cos theta is 1. X theta plus 1. And z prime will be equal to z. Clear? Now, what happens? That the wave function at a point xyz, that is psi xyz, must be equal to the value of the final wave function at x prime, y prime, and z prime. That means rotation should not change the wave function. Rotation should not change the wave function. All right. So in that case, what can we write? So my psi rotation x prime, y prime, z prime must be equal to psi f y z. Okay. Now what is psi x prime y prime? What is this one? Psi r x prime y prime z prime. That I can write. What I can write? That psi. कौन हबो s जगह x prime जगह केते लिखिबी
X minus.
x minus y theta. Here. Similarly, y जगह केते लिखिबी y plus x theta plus y or y plus x theta. Right? Isn't it? And z prime.
Z.
Z. Right? Now if I'm trying to write, this is I'm writing in terms of x, y, z. If I try to write in terms of x prime, y prime, and z prime, x prime, y prime, and z prime, so what will happen? That will just be the inverse. It will just be the inverse rotation of this one. So then, instead of this x minus y theta, it will be x prime plus y prime theta, x prime plus y prime theta, and y minus, because theta goes to minus theta. You take it that way. तार कौन है जदि मु गोटे स्टेट अच्छी ताकू थीटा एंगल रोटेट कर देली ताले मते कौन मिलबो x प्राइम y प्राइम z प्राइम सेटा को जदि मु x y z रे लिखिया पई चाहिबे ताले ए जो ऊपर लिखितली तीनटा इक्वेशन है ताकू यूज करके लिखि किंतु जदि मु नुआटे लिखिया पई चाहिबी रोटेटेड सिस्टम रे लिखिया पई चाहिबी तार माने कोन भाबिबी जे सिस्टम टा माने एक्सिस टा माइनस थीटा रोटेट एक्सिस टा मोर माइनस थीटा रोटेट तेणु एठी थीटा जेटा थिला थीटा जगह माइनस थीटा सब्स्टिट्यूट तेणु एक्स एक्स माइनस वाई थीटा थिला तो सेटा हे जो एक्स प्राइम प्लस वाई प्राइम थीटा आ एठी कोन थिला वाई प्लस एक्स थीटा सो दैट विल बी वाई प्राइम माइनस so here it will be y prime minus x prime theta and z z becomes z बुझियला
On, sir.
Yes, sir.
so that is basically your equation number 1.38 a b and c that's what it is telling me all right okay I'll possibly stop it here because we had class at 5 also right so any questions up to this point I will continue from here in the next class so how exactly the wave function psi will change with theta and what will the generator we are basically looking for generator for rotation ଯେମିତି ଆମେ translation ପାଇଁ generator ବାହାର କଲୁ ସେଟା କିଏ momentum right ସେମିତି rotation କରିବା ପାଇଁ generator କିଏ quantum mechanics ରେ rotation କରିବା ପାଇଁ generator କିଏ that will but any question up to this point
No, sir.
okay then I will stop it here so tomorrow at same time tomorrow same time I will take the class and I will start from this point onwards okay
Yes,
Okay,
sir.
sir. Thank you, sir.
Thank you, sir.
okay. Thank you for your attention